Problem B1. The Muon Shot. In 2023, American particle physicists recommended developing a muon collider to investigate the nature of fundamental particles. Such a collider requires much less space than other options because of the muon's high mass m, which makes it easier to accelerate to a very high energy, E, much greater than mc². Question A. When a muon collides head-on with an antimuon, which has the same energy and mass, a new particle of mass 2, E, over c² can be produced. If the antimuon was instead at rest, what energy would the muon need to produce such a particle? Unfortunately, muons and antimuons are unstable, with lifetime tau. That is, if one such particle exists at time t equals 0. Then in its rest frame, the probability it has not decayed by time t is e power negative t over tau. Question B. Suppose the muons begin at rest, and are accelerated so that each muon's energy increases at a very large, constant rate alpha in the lab frame. Find the fraction f of muons that have decayed by the time each muon has energy, E, assuming f is small. The collider produces a bunch of muons with energy, E, uniformly distributed in a thin disk of radius r equals 10 power negative 6 meters. It also simultaneously produces a similar antibunch of antimuons. For simplicity, model each muon and antimuon as a sphere of radius r equals 10 power negative 21 meters, and suppose a muon-antimuon collision occurs whenever two such spheres touch. Question C. Initially, the bunch and antibunch each contain n equals 10 power 14 particles. If they immediately collide head-on, what is the average number of muon-antimuon collisions, to one significant figure? Question D. The bunch travels clockwise along a ring of circumference, L, equals 10 kilometers, while the antibunch travels, along the same path in the opposite direction. Assume all particles maintain a constant energy, E, equals 10 power 5 mc², and that the muon lifetime is tau equals 2.2 by 10 power negative 6 seconds. To one significant figure, what is the average number of muon-antimuon collisions that occur before all of the particles decay?